So, you all just discovered formula. What did you do to solve for x here? We took 10 cosine of 30 degrees. What was 10? R. 30 actually came from what actual angle? The 210. So really what you did is you did 10 cosine of 210 degrees. We cut it down to the reference angle, but really that's the same thing as doing cosine of 210. So to find x, all you did is take r times the cosine of theta. To find y, all you did was take r times the sine of theta. That'll find it every single time. That's all you have to know to find it. You want to learn those because they're going to be big in the next chapter we do as well. So knowing r cosine theta and r sine theta is well worth your time and trouble. Save you a lot of headaches later. So if you want to find x and y, that's all you have to do. So if I gave you one that was nasty numbers, suppose I gave you r was 8/3 and the angle is 173 degrees. How are you going to get x and y? You're going to do, you don't even have to draw the picture now that I gave you those formulas. You're going to go, oh, I need to do 8/3 cosine of 173, and y is 8/3 times the sine of 173. Since that's not a special angle, you're going to throw it in your calculator and get the decimals, and you're done. No, I had to prove to you what works. You never do it for nothing. Jimmy. Now, if that was a special angle, you would have still drawn this picture and found your reference angle and figured it out, because I expect you to use special angles. But, okay, I don't know what those decimals are, so unless somebody's going to punch that in for me, I don't know what those final answers are, but that's all it takes. All right. All right. Now, you're going to take what I just taught you. What I just taught you is the exact same thing I'm about to do here. But for some reason, I can't get people to make that connection. Now I'm going to turn this thing to complex numbers. Okay. Last time we were doing rectangular coordinates. Polar coordinates. You need to read the words. Not see the word polar or rectangle, you need to see what comes after it. I cannot tell you how many people mess this up come quest time just because they didn't read the instructions. Okay. Now I'm talking complex numbers. Everything we just did is exactly the same here. But when we're talking complex numbers, my rectangular form is x plus yi. When you graph a complex number, if I give you 2 plus 3i, we've graphed these before. You have the x-axis is the real axis, the y-axis is imaginary. So if you graph 2 plus 3i, you are going over 2 on the real, and you're going up 3 on the y-axis. But it's not a point. A complex number is a thing called a vector. We're going to spend a ton of time with. We're going to do vectors on our next chapter, big time. But all that is it means a vector is a line segment that goes from here, stops there, but it moves in that direction. It forms a triangle again. So all we know is that we went over 2, up 3, and we have an imaginary or complex number when you graph it. Okay. I want to change it into polar form, meaning I want it in radius and angle as opposed to over 2, up 3. I want to know what radius and angle did I go at. Okay. You guys already know the secret. We just did it. What did we just find out x was on the previous screen?
X was radius.
We just found out x was radius times cosine, and y was radius times sine. Okay, so all I'm going to do is replace x and y in my complex number with those. So I'm going to have x is r cosine theta plus y is r sine theta times I. Now, mathematicians looked at that and went, That's kind of hard to read. And the big problem is people think that the I is times the angle. Is the I times just theta? No. The I is times that whole thing. So they kind of went, we need to write this a little differently to avoid confusion. And they noticed that, hey, dude, they both have an R. So they said, let's pull the R out front. It's just R times cosine of theta. And they chose to put the I in front so there's not confusion. I times the sine of theta. That way you know it's times the whole sine, not just the angle. That is polar form of a complex number right there. Okay, that is going to be your best buddy for all through Thursday. Everything we do, remember I said we were going to take those complex numbers to a big power to big power? It's in that form that we have to do it. So this form is our friend. It is. It's your friend. You love that formula. It's your best friend.
My friend's a liar.
Okay. I will also point out, in case you run into a different trig book, I prefer polar form as the name of this because it goes with polar coordinate. You see the word polar and you think R theta. You think radius and angle. There is a second name for this. I don't like it, but they also call this trigonometric form. So if you're sitting in a college trig class or you happen to have the joy of Calc 2, but I think in Calc 2 they always call it polar, that's trigonometric form is the same thing as polar form. You see those words. It's got, it involves trig, so it does have a connection. But people don't always immediately think radius and angle. They don't always think R and theta with it as much. So I like polar. I've had, every time I switch textbooks, it seems like the next book I get does the opposite name. They switch back and forth in what they call it. But it is the exact same thing. Okay. Because you know the previous formulas we just did, you already know how to convert between these two forms. I just need to make you realize that you know this already. So if I said to you, convert 5 minus 5i to polar form, what would you do?
We have to get to R.
We have to find R and theta. How do I do that? Draw a picture. That would be a good start. Where would I draw the picture? Where do I know this thing? So this would be, so this is indeed X and Y here. So I'm over 5 to the right. And then, since that's negative, I'm actually down 5. Don't put the I on that. It's a complex number, but when you're doing the coordinates here, don't put the I on there. It will mess up your math. It's just 5 and negative 5. So in other words, I know X and Y. How am I going to find R and theta? Pythagorean theorem. Okay, so 25 plus 25 equals, yeah, okay. And you're going to break that down, of course, because you're going to go, well, shoot, that's, oh, come on, guys. You have 25.
Yeah, so
It'd be 5 times the square root of 2.
Thank you. It'd be 5 times the square root of 2. You scare me. That's just 5. If there's 2 25s in it, there's going to be a 5 on the outside, and the 2's going to be on the inside. It works that way every time. Okay, so that's R. How did I get the angle back there on that other screen? Tangent. We went, oh, I need, to find the angle, I need tangent. In this case, it's what over what? Technically, negative 5 over 5, which is negative 1. Okay, do we need to go to our calculator to get this answer? Do we know where tangent equals 1 at?
45.
45, yes. So since we know tangent equals 1 at 45, what action, now this is the part everybody does. They always tell me 45 is the angle. That's why you need the picture.
360 minus 45.
Yeah, 360 minus 4. We're going clear around there. So 360 minus 45 is really 315. So yeah, your angle here is actually 315. Then, the last thing you need to do is you need to ask yourself, how did they want me to write the answer?
Polar form.
in polar form. This, r cosine theta, I sine theta, that's polar form. So yeah, it seems like that's a lot to write out. There's going to be a reason for that form next class. So r is going to be 5 square root of 2 cosine of 315 plus I sine of 315. And that, in this case, since they asked you to just convert it and quit, that's all you're doing. You converted it. That's your final answer. Okay. There is a shortcut to this, and I hesitate to say this because you all tend to use shortcuts more than you should. But I think there's a problem on your assignment that writes it this way. Sometimes, if we're not calculating with this and we're just writing out this form, people don't want to write out the cosine, I sine all the time. So they abbreviate it. So an abbreviated form of this, they will write CIS for cosine I sine 315. So close to CSI, but it's not. It's CIS, cosine I sine. So if you see that, it's the same thing as this. They're just shortcutting, writing all that out. So it has its moments. If you're not trying to work a problem, if you just want to list answers, it is really efficient. There's a time to use it and a time to not use it. So, but you can do both methods. Are we having fun yet?
I'm bored to death. You ain't gonna get. I'm so tired.
I probably better at least give you a hint to the last one. We'll just throw one on here. How do you get backwards? What if I gave you this form? What's an angle we haven't done yet? Oh, let's do that. Okay, if I give you polar form, how do you get back to rectangular?
Okay, well, you have to draw that angle.
Okay, you would draw a picture. And where would you draw this picture? And since we're on 270, it's on the line, baby. So this one's actually going to be extra easy. But essentially, all you need to do here, you just need to figure out what's the cosine of 270 degrees. Don't we already know that? I'm on the same line as 90, so it's the same thing as cosine of 90, which is 0, okay? And if it's 0, I need the sine of that same angle. So if cosine is 0, that means sine is 1. But I'm on the negative side, so it'd be times negative 1. Okay, so now multiply that together. Technically I have 0. They'll write it as minus 2i, or actually just minus 2i, and in that case would be the back to that other form. But if they're giving you polar form like this, just figure out what's the cosine of that angle, what's the sine of that angle, fill it in.
So those are two okay.
Yeah. So to be able to do Thursday, you have to be able to go back and forth between these two forms all the time. We switch back and forth constantly, depending on what we want to do. No, you would not have 0 on that. Not necessarily have 0. But once again, you'll love it if it's sitting on the quadrant line. Makes your life easy. This is not bad.